Chapter 3 Nuclear Energy 3.1 Nuclear Fission and Fusion. Let's begin. A trip to Mars. Nuclear fusion may provide a lot of energy. Compared with chemical energy, nuclear fuel has very high energy density. A spaceship powered by nuclear fusion can be relatively light and yet powerful. However, a fusion reactor is not yet developed. 1. Nuclear fission. There are over 400 fission reactors all over the world, including 2 at Daya Bay nuclear plant. When a heavy nucleus breaks into 2 or more nuclei, nuclear fission occurs and nuclear energy is released, mainly in the form of kinetic energy of the fission products. For example, the fission reactors at Daya Bay uses uranium-235, which typically splits into 2 when a slow-moving neutron is absorbed. 2 fission neutrons are emitted in the fission along with the nuclear energy. It is interesting to find that the nuclear energy comes from mass. Uranium-235 undergoes fission. The total mass of the product side is smaller, and the loss in mass becomes nuclear energy. The amount of energy released in such a fission is enormous. 2. Chain reaction and critical mass. Fission of uranium-235 nucleus is triggered by slow neutrons only. The fission neutrons are fast-moving, on the other hand, and so they have to be slowed down. If there are enough uranium-235 nearby, the fission neutrons may help to split other uranium-235 nuclei. The process continues, and a chain reaction of nuclear fission results. Larger than a certain critical mass, so that the percentage of fission neutrons captured may sustain the chain reaction. In other words, when there are too little uranium-235, a lot of the fission neutrons may escape from the reaction core, and chain reaction cannot occur. Example 1. Fission of plutonium. For part B, there must be at least 1 fission neutron for chain reaction to be possible, and now 2 fission neutrons are produced. And of course, the mass of plutonium fuel must be larger than the critical mass for chain reaction to occur. Example 1. Possible chain reaction. As was mentioned, the necessary conditions for fission of uranium to sustain includes: number 1. Mass of uranium-235 is larger than the critical mass. Second, more than 1 fission neutron is produced per fission. Number 3. The neutron's speed after moderation should be slow. And so in this case, considering the number of fission neutrons, only 1 and 3 are possible, while equation 2 does not produce any fission neutrons for chain reaction to sustain. 3. Nuclear fusion. In nuclear fusion, 2 small nuclei fuse together into 1, and nuclear energy is released. As the product is more stable, the energy released by fusion per unit mass is about several times that by fission. Nevertheless, nuclear fusion is difficult to start. As all nuclei are positively charged, they must have very high kinetic energy to approach each other at high speed. So the temperature of the fuel must be extremely high. And a very smart scientist find a way to start fusion, but in an uncontrolled manner, in a hydrogen bomb. You should note that while energy density of fusion is higher than that of fission, each single fission reaction releases more energy than a single fusion reaction. Lastly, hydrogen fusion is not uncommon. It occurs at the center of the Sun, which is the source of solar energy. Example 2. Fusion of nitrogen and hydrogen. Fusion of nitrogen and hydrogen is also possible. It occurs at extremely high temperature. Do check point 1 on the next page.